Good afternoon. This is G. Om Kedareshwar Kiran from Institute of Aeronautical Engineering at Department of Electrical and Electronics Engineering. Today's we are going to discuss about nonlinear circuit theory and its applications as follows, and how they are applicable in analog circuits. Now, let us know about nonlinear circuit theory and application. Nonlinear circuit theory explores the behavior of electronic circuits with components that do not follow a linear relationship between voltage and current. Here we are going to know about a nonlinear circuit which is having a behavior of electronic circuits with the components of linear relationship which does not maintain between voltage and current. The field encompasses the wide range of applications from power electronics to analog signals processing. It allows the simplification of the measurement and calculation of the output of a circuit which has more than one input signal applied to it at any one time. Now, here what it is going to say is it also allows the simplification of measurement of a calculation of the output circuit which has more than one input signal. Means when the circuit having more than one input signal, then only the simplification and the measurement of the calculation of output circuit is be done at applied to any one time. The output with all the signals applied at the same time is the sum of the output with each of the input signal applied at one time. Now, introduction to nonlinear circuits. Uh, Let us know about nonlinearity. First, what is nonlinearity? Circuit containing components like diodes, transistors, or vacuum tubes exhibit nonlinear behavior, meaning their input-output characteristics are not proportional. Complex dynamics. Nonlinear circuits can display complex dynamic behavior, including oscillations, shocks, and purifications, which are not seen in linear systems. These complex dynamics are going to say what is the oscillations and shocks purification, which has not seen in the linear system of nonlinear circuit display. Design challenges. Now that what about the design challenges is analyzing the designing nonlinear circuits, specialized techniques beyond the methods used in linear circuits. For the design of the linear circuits, the nonlinear circuits requires a special technique uh, which already used in beyond the linear circuit. Now, nonlinear resistors and its voltage and current characteristics. Before going to the nonlinear resistors, let us know about what is Ohm's law. As we know, the Ohm's law is dependent upon the voltage, current, and resistor. What is the definition of the Ohm's law? At const at constant temperature, the current passing through the conductor is directly proportional to the potential difference between the two endpoints of the conductor. It is known as Ohm's law, where the voltage equal to current into resistance V equal to IR. Now, coming to the nonlinear resistor and voltage and current characteristics, let us know about the nonlinear resistors. Non-resistors with nonlinear voltage and current relationship, such as variosis and thermistors, exhibit behavior of deviates from Ohm's law. These resistors and thermistors, they exhibit in the type which it deviates from Ohm's law, where voltage is equal to current into resistance. In a high contrast, a linear circuit has a straight line graph that passes through the origin, indicating that the resistance is constant. When the straight line from the gap passes through an origin, the resistance is constant. However, most electronic components only exhibit linear characteristics within a specific region. We know that the most electronic components have a linear characteristic within a specific region, means within a specific bounded area. For example, a diode has a linear characteristics within narrow operating range. Now the voltage and current characteristics. The voltage characteristics and the current characteristics of a circuit stands for the voltage current characteristics, that is VI characteristics of a circuit. The graph of the current and voltage is drawn on the graph to show how one changes when change in other is done. Means if voltage changes, the current also changes, and current changes, the voltage changes. It is voltage and current are directly proportional to each other. The slope of the graph gives resistance, but only in the case when the slope is linear. Does what it mean the non-linear graphs of VI characteristics are present too? Yes, there are both linear and non-linear characteristics of these graphs exist. Ohm's law would not have been valid. Ohm's law exists and so does the non-linear graph. The reason behind this is so-called contradiction is simple. Although Ohm's law is applicable and true for a lot of materials, it has not applicable for some materials where the law of proportional it does not work. These types of diodes or non-linear graphs or something materials, they are totally proportional to Ohm's law, so that does not work. Let us learn about the different types of nonlinear capacitors and dynamic behaviors and its dynamic behaviors. The first one is voltage dependent capacitance. Now the voltage dependent capacitance, let us know about the voltage dependent. Nonlinear capacitors such as a vector diodes have a capacitance that varies with the applied voltage. When the nonlinear capacitors of diodes capacitance varies with the voltage which we have applied from the source. Applications. These applications of a nonlinear capacitors are used in applications of filters, voltage control oscillators, and parametric amplifiers. Now the last one is dynamic response. It is not important, but it is necessary to say about these dynamic responses because they are independent on dynamic capacitor behavior. This dynamic behavior of a non-linear capacitor can lead to phenomena like hypothesis and memory effects. We already know that the what are the memory effects in data or different types of analyzing responses. Now, coming to non-linear inductor and magnetic saturation. We know that a magnetic saturation is a type of non-linear inductors. Here we can see the diagram on the left side. The non-linear inductors such as iron core inductors exhibit magnetic saturation where the inductance decreases at high current levels. And the hypothesis losses. What are the hypothesis losses? Magnetic hypothesis is a nonlinear inductor causes energy losses which must considered in a circuit design. In a circuit, every circuit design, the energy losses are occurred. These applications, nonlinear inductors are used in power electronics, switched mode power supply, and magnetic amplifiers, and analysis challenges. Modeling and analyzing nonlinear inductors requires advanced techniques such as use in the Frickes models. Now, analyzing a nonlinear circuit, we can see the left side we have a diagram of where the inductor is varied. Inductor is got varied and the resistance is kept constant. First one is graphical method. Graphical techniques such as load lines and phase planes analysis can be used to study the behavior of a non-linear circuits. These all are okay to study about the non-linear circuits. Numerical methods, computing applied analysis of numerical techniques like Newton-Raphson method and the necessary complex of nonlinear circuit. Perturbation method. Perturbation method through theory to the harmonic balance techniques allow approximate analysis of the solutions of nonlinear circuits. Application of nonlinear circuits are power electronics, analog signal processing, communication systems, and control systems. In the power electronics, The nonlinear circuits are fundamental in power electronics, including the power supplies, motors, drives, and power converter. We can see that the left side diagram input and output of the power converter, which is from one dimension to other dimension. The second one is analog signal processing. Nonlinear circuits are used in analog signal processing for applications like waveform, shipping, maxing, and compression. Communication systems. Nonlinear circuit plays a role in communication systems such as a modulation, demolition, and frequency conversion. Control systems. Nonlinear control theory is used to analyze and design the feedback systems with nonlinear components. Now, coming to the conclusion, the future trends, conclusion and future trends. What are the future trends of this nonlinear circuits? Nonlinear circuits theories continues the evolve and driving the increases complexibilities of modern electronic systems and need of advanced functional feature trends, including the exploration and emerging nonlinear devices. The development of more efficient analyzing techniques and the immigration of nonlinear circuits is going to cut edge applications. So these are about the nonlinear theory and nonlinear circuit theory and its applications. We briefly explained about the nonlinear circuit theory and its applications. Thank you.